Alright, today's topic is systems and matrices. We all know what a matrix is. It's just numbers in a box. Nothing complicated about that. The determinant of a matrix is found by multiplying the first and last numbers of a matrix and subtracting the middle two. So 4 times 1 is 4, 2 times 3 is 6. 4 minus 6 is negative 2. So the determinant is negative 2. The determinant of this matrix is 0. Note, you cannot find the inverse of this matrix because it has a determinant of 0. To find the inverse of matrix, you multiply 1 over 0 by a slightly modified matrix. You flip the first and last digits, and you change the signs of the middle two. Now, this doesn't have an inverse because, well, the denominator is 0. You can't multiply by 1 over 0. So we'll skip that. Last thing, multiplying matrices. When you multiply a matrix, first of all, you look at the dimensions. This is a 2 by 2 and a 2 by 2 matrix. You'll notice that the middle two are the same, which means these are compatible matrices. Now the last two show you what the dimensions of the resulting matrix will be. So this will end up as a 2 by 2 matrix. Split the first matrix into rows and the second matrix into columns. Multiply 2 by 3 and you get 6. Multiply 2 by 3 and you get 6. That is the upper left number of the resulting matrix. Multiply 2 by this 3 and 2 by this 3 and you get another 6 plus 6. Obviously, this is a really easy matrix, so you'll just end up with a lot of 6 plus 6. And that's your resulting matrix.
So we have this problem, 1342a equals negative 3526. So this could be represented as x. A is equal to y. Now to solve for a, you do the a is equal to the inverse of x times y. So then the inverse would be a is equal to negative 1 over 10, which is the determinant, multiplied by 2, negative 3, negative 4, and 1, which is the inverse. And then you multiply that by the other matrix, which is negative 3, 2, 5, and 6. Now when multiplying, you just split that up, and then, so the 2 and the negative 3 is negative 6, and then the negative 3 and the 2 is minus another 6, or that's a 6, and then so on and so forth with all of the terms.
I think I saw one of
And then you still have that determinant there. And then you add all the terms and then multiply them by the determinant.
No, you don't. You multiply the determinant to find the inverse, and then you multiply.
No, this still works. It still works. And then, so you should get 1.2, negative 1.4, 0.8, and 1.4. And there you go.
my calculator doesn't
Alright, and then we have this next one, which is a system of equations. So it's 2x minus 3y plus 4z is equal to 11, and negative x minus 2y plus 3z equals negative 13, and 3x plus y minus 2z is equal to negative 7. So you can set this up as a few matrices. You're solving for x, y, and z, and then it is equal to 2, negative 3, 4, negative 1, negative 2, 3, 3, 1, negative 2, and then the inverse of that multiplied by 11, negative 13, and negative 7. So what you do on your calculator, which you have right here,
First, you turn the power button on.
and then you go second matrix, and then you have a list right there, and then so you plug in the numbers, so you have A, and then you do the inverse, which is right here, and then times matrix B, and then you get 44, 355, and 247. And then those are your answers for X, Y, and Z.